As instructors, we should always be trying to improve the courses that we teach. We should never sit on our laurels and just say this course is good enough. It's because there's always ways in which we can improve it. One thing I've found in working with students over the years is that they tend to lose the connection to reality when they're working through the math of a model. So I'll give them a problem, and then when they work through the model, they think about the pieces just as letters and operators, and they manipulate it like it's a math problem. And then at the end, they'd be like, all right, and then I get this answer, and it's p equals -0.3. They don't see a problem with that because it's just p. Whereas an expert would notice, well, p is actually the price, and prices can't be negative, so I must have made a mistake along the way. But then I ran across a site called econgraphs.org, which has manipulable graphs. So instead of just saying, this is how profit maximization works and showing you some algebra, it has a picture. And the picture is a lot like what you would see in a textbook, except you can change parameters of the model and see how the graph changes. That's where the whole thing came together. So my job was next, how do I get students actually using these models? So I hired 3 undergraduate students that had done very well in the class to translate existing exercises and create new exercises for students that actually used these visualizations and helped students build intuition for how the models work.
By having these interactive graphs and having more hand-on experience and by fidgeting with them, I hope that it leaves more of an impression on them that will not only translate to better memorization, but also a more fun experience for both the teacher and the learner.
In addition to adding the models into existing problem sets, we also kind of took some liberties and were creative and created some interesting problems ourselves. I know that we had one called Kit Kats and Oreos, and I think that we just had a little bit of fun with it ourselves.
Some of the exercises used visualizations straight from the website, but in many cases the students had to customize these visualizations by writing code and making the figures match perfectly with the goals of the exercise.
I can use one particular example. So professor, he was giving this lesson and he was drawing all these lines on the board and it got very messy. And so the graph that we made, we incorporated sliders and you can move points around and the lines are much more clear. You have all these nice curves. It's much more effective as a visualization tool.
So a key part of the development process for these exercises was called the Think Aloud interview or Work Aloud interview, where we would bring back students who had taken the class and they would work through the problems, verbalizing their thought process while we watched them and took notes.
Move this slider until Rohan has the same utility as the original consumption bundle. I'm doing that now. Oh, it's 7.1.
So in words, what is that telling you?
How much you have to pay Rohan so that he's as good off as he was before the change.
Right. And what's that measured in?
CV, I think money.
Yep.
Dollars.
Yeah, you'll give them dollars, exactly.
I think it was more helpful to be able to move the lines than just see the graphs on lecture slides. Remembering what each line actually represents.
Right. I think what I'm getting out of this is there's going to be, for every student, there's going to be a process where they have to learn really how the graph works.
What I took away from this project is that I think I understand a little bit more about how to write these problem sets and how to write assignments as a teacher. I think that's a really rewarding experience because you get to see what concepts you need to teach these students and how to convey that information that helps students not only with a test but actually understanding material.
Just showing people these models doesn't cut it. You have to have the students manipulating the model and getting feedback. There has to be this tight feedback loop. That's the power of it. The power is not the showing. I mean, this is active learning all over again, right? The power is not the lecturing clearly. The power is getting them to solve problems in ways that they get practice succeeding and failing. And that's where the learning actually happens.